Good afternoon. Today's topic is the principle of inclusion-exclusion. Before we start the principle of inclusion-exclusion, we have to know a little bit about sets. So what do you mean by sets? Set is a collection of unordered collection of objects. So first we have to know about set. Set is a unordered collection of objects. Okay. And then whenever we are talking about sets, it is represented by capital letters A, B, C, etc. And the operations performed on sets will be union and intersection, which you might already know. So union is basically the combination of two sets, which includes all the elements of both the set A and set B, while intersection takes only the common elements. So now, what does principle of inclusion-exclusion mean? So the principle of inclusion-exclusion is also known by another name, which is known as the sieve method. It is also known by the name sieve method. And basically, whenever we have two sets, if the sets are disjoint sets, okay, so this is another term, disjoint. Disjoint means the set whose intersection value is 0. That is, there are no common elements. So if the sets are disjoint, then the union of those two sets will be the total elements of both the set. Okay. So in that case, if we have A and B, if there are 3 elements in A, 4 elements in B, then the total elements in A union B will be 7, only if the sets are disjoint. What if the sets are not disjoint? Okay, so what if the intersection is not equal to 0? Then what is the case? That is basically the principle of inclusion-exclusion. Now over here, first let's consider an example. So I'm speaking about some club, an English club or a literature club, which contains 30 female students and 50 juniors. Okay, so I'm speaking about some club in a university or a college which contains 30 female students and 50 juniors. How many students in the class are either female or juniors? Okay, so if the question is how many students in the class are either females, or in the club actually, so this is in the club, are either females or juniors. Now in this case, what we need to know is how many students in this juniors are females. Okay, we don't know how many students in the juniors category are female. Okay, there may be a few females, there may the entire juniors will maybe of females, or even there might not be any females in the 50 juniors that you have in the club. So now for this question to be answered, we need some more information. Okay, so in this case, for counting such type of problems, we use this principle of inclusion-exclusion. Okay, so let's move on. So basically, some rule is if sets A and B are disjoint, then A union B is the cardinality of A. So this symbol denotes the cardinality. Cardinality is basically the number of elements in A. Cardinality is basically the number of elements in A. So A union B, if the sets are disjoint, disjoint means there will not be any intersection or any common element in between the two sets A and B. So cardinality is the number of elements in A. So how many elements will be in A union B? The number of elements in A union B will be total elements of A plus all the elements of B. So that is very simple. If there is no intersection between A and B. Now what about if there is intersection between A and B? That is, these two sets A and B are intersecting in such a way that there are some common elements in this way. Now what will happen in that case? So what if A and B are not disjoint? What will happen in that case? So for two arbitrary sets A and B, if they are not disjoint, that is this portion that is shown here overlapping is the intersection part. That is, here there are some elements which are intersecting or which are common to both A and B. What will be the scenario in that case? In that case, A union B will be equivalent to A plus B. And why are we doing A intersection B minus A intersection B? Because if we are taking simply A plus B, the common elements will be counted twice. If we are taking, if simply cardinality of A and B is considered, then in that case, elements will be counted twice. Okay, so if elements are being counted twice, then it will not give us an accurate result. For that reason, you have to subtract the intersection of elements once. Okay, so that is the reason we have to subtract. We have to perform the subtraction. Okay, so this is the inclusion exclusion principle on two sets A and B, and this is the formula. It is very important, and it is usually given in a 5 mark. It is a 5 mark question in your essay question. Based on this, we will look at a few examples. So let S be the set of integers from 1 through 1000 that are multiples of 3 or multiples of 5. Now, so in this case, we are talking about S, which is a set of integers from 1 to 1000 that are multiples of 3 or multiples of 5. Okay. Now we have to find what is the total number of S, what is the cardinality of S. So let A be the set of integers from 1 to 1000 that are multiples of 3. So we will divide the problem in such a way that we will first consider multiples of 3, and then we will consider multiples of 5, and we will remove the elements which are both multiples of 3 and 5, such as 15, 30, 45, etc. Okay, those elements will be counted twice. For that reason, we have to remove the element that is the intersection part. So let B be the set of integers from 1 to 1000 that are multiples of 5. Now it is clear that S is the union of A and B, but notice that A and B are not disjoint. What does it mean? That means that if we have A, B, and if A is the multiple of 3, it means we will have 3, 6, 9, 12, and 15 is a multiple of even 5. So 15 will be in the intersection part. While for the multiples of 5, we will have 5, 10, 15 is over here, 20, etc. So in this case, we have to remove the elements which have been counted twice. For that reason, we have to consider we have to remove the elements which have been counted twice. So this is the intersection shown over here. Okay, A and B. Now, how many elements are there which are multiples of 3 from 1 to 1000? We can easily find out that by dividing 1000 by 3. That is, if you have the last number which will be a multiple of 3, which is less than 1000, will be 999, and 999 is divided by 3, we get 333. Okay, so over here, whenever we want to find the multiples value, we always have to take floor value. Okay, this has not been mentioned, but we have to take floor value. If you're not understanding this, consider from 1 to 10, a simple example from 1 to 10. Now in this case, if you are considering from 1 to 10, how many multiples of 3 will exist from 1 to 10? So you will have 3, 6, 9. Okay, there are 3 multiples. If you want to find that directly, what you can do is you will divide 10 by 3 and take the floor value. So 10 by 3 will give you 3.33 something. Now in that case, what is the floor value? You have to just consider 3. So there are totally 3 multiples which are given over here. So in the same way, for 1000, you have to divide 1000 by 3 and take the floor value. The next will be for multiples of 5. Similarly, you have to divide 1000 by 5 and take the floor value, which will give you 200. Now, what about multiples of both 3 and 5? What about this intersection part? Now, for that part, if you are taking this symbol denotes intersection actually. A intersection B is the set of integers that are multiples of 15. Why? Because 15 is a multiple of both 3 and 5. Similarly, we will get 30, 45, 60. So this basically, the set of numbers is basically all the numbers which are divisible by 15. So A intersection B is the set of integers that are multiples of 15. And so A intersection B will be the floor value of 1000 by 15. So it will give you 66. Now, how do we have to find the formula? How do we have to use the formula? To use the formula by inclusion exclusion principle, S is equal to A plus B minus A intersection B. So this is minus A intersection B. So 333 minus plus 200 minus 66, which will give you 467. Okay. So this is an example problem for the principle of inclusion exclusion. Similarly, we will see a few more example problems. So the first problem in discrete mathematics class, every student is a major in computer science, that is, he is majoring or getting a degree in computer science or mathematics or both. Okay, so we have a class of discrete mathematics student where they are either studying computer science or mathematics, or they are even studying both. The number of students having computer science as a major, possibly along with mathematics, that is, the students having computer science and even they may have mathematics, is 25, and the number of students having mathematics as a major, possibly maybe along with computer science, is 13. So these two numbers are also including the intersection part. So if we see this diagram, computer science students and mathematics students, there are a few who are getting both in both the streams or both the departments. Okay, and the number of students majoring in both computer science and mathematics is 8. How many students are there in the class? Now, for this problem to be solved, let's just note down the numbers first. So the number of students studying computer science, so for that I'll denote C as 25 and M as 13, and then C intersection M is given as 8. So just remember the number, we will solve it over here. So let's write it. Let C be the students. C be the students in the class in computer science, that is getting a degree in computer science, and M be the students getting a degree in mathematics. Then C intersection M is the students getting a degree in both computer science, and mathematics. Now, because every student in the class is getting a degree in either computer science or mathematics or both, it follows that the number of students in the class will be C union M. Okay, so the total number of students in the class are C union M. What is the formula? C plus M minus C intersection M. So we know the values. So C value, the number of students getting a degree in computer science, is 25. So this is given as 25, while this number is 13 and the joint getting degree in both is 8. So 25 plus 13 minus 8 will give you the result 30. So therefore, totally how many students are there in the class? 30 students are there in the class. This can also be represented by a Venn diagram. What does a Venn diagram mean? That is, a graphical representation of sets is known as a Venn diagram, and you can represent it by using a Venn diagram also. Next, the next question is, how many positive integers not exceeding 1000 are divisible by 7 or 11? So the positive integers divisible by 7 or 11. This question is similar to the one that I have done with 3 or 5. Okay. So in that case, what you can do is, you can consider the values 7 and 11 and follow the same method as I have shown you in the earlier example. Let's see. So A be the set of positive integers not exceeding 1000 divisible by 7, that are divisible by 7, while B be the set of positive integers not exceeding 1000 that are divisible by 11. Okay. Now, then A union B is the set of integers not exceeding 1000. What is A union B? A union B will be the set of integers, positive integers not exceeding 1000 that are divisible by either 7 or 11. And what will be A intersection B? A intersection B is the set of positive integers not exceeding 1000 which is divisible by both 7 and 11. Okay, so this will be, the earlier one was either, this will be by both 7 or 11. Now, to find the total number of integers, what is the formula? A union B is equal to A plus B, cardinality of A plus cardinality of B minus cardinality of A intersection B. So what is the cardinality of A? Cardinality of A will be given by 1000 by 7. We have to take the floor value. Similarly, 1000 by 11. Take the floor value once again. And A intersection B, as I've already explained, we have to take 7 into 11. That is 77. Such numbers will be divisible. So that are the common elements. So 1000 by 7 into 11. The reason I am taking the 7 into 11 has been already explained in the previous example. Now 1000 by 7, what is the floor value? It will give you 142 point something. So 142. Similarly 90. And how many common elements are there? There are 12 common elements. So 1000 when divided by 77, the floor value will be 12. Now, what are the total number of numbers which are not exceeding 1000 and are divisible by 7 or 11? The total number of integers is 220. So, this is the solution. What is the next problem? The next problem is that, suppose that there are 1807 freshmen, or you can even consider the term juniors at your school. Of these, 453 are taking a course in computer science, 567 are taking a course in mathematics, and 299 are taking a course in both computer science and mathematics. How many are not taking a course either in computer science or in mathematics? Now this problem is a bit different from the ones we have done earlier. What is different? So already it has given you the number of total students in your school or university. So number of total juniors in your school or university. So let's write that. To find the number of students who are not taking a course in computer science or in mathematics, you have to subtract the number that are taking a course in either of these subjects from the total number of students. So basically, if this 1807 is the universal set U, then you have to subtract universal set minus A union B, cardinality of both of these. Okay, so this is the problem. Now what is the value of A union B? A union B has not been given in the question. You have to find the value of A union B. So let's just note down the numbers. Total number of students taking a course in computer science. I'm denoting it with A. You can even take any term. Earlier I've taken C. So A is 453 and B is 567 students taking a course in mathematics. And what about in both computer science and mathematics? A intersection B will be 299. Okay, A intersection B is 299. Now we have to find A union B. So for that, let's take our A union B. We have to find is A plus B minus A intersection B. That will give you 453 plus 567 minus 299, which is equivalent to 721. Okay. Now, how many total students were there? The total number of students were 1807. So this was our universal set. If I want to denote in the form of a diagram, I can denote it in this way. So this is denoted in this way. So if this circles that I have drawn are A and B respectively, while this is your total university students U, then we have to find this part. The ones who are not taking the course either in computer science or in mathematics. So this blank part, apart leaving the circles, we have to find that. So we have been given universal set 1807 and we got this entire A union B as 721. So the number of students who are not taking a course, let me write that. Students who are not taking course in computer science or in mathematics will be equivalent to 1807 minus 721, which is equal to 1086. So these are the number of students who are not taking a course in computer science or in mathematics. They are taking a course in some other subject. Okay, so this is the solution for your question. Now let's see the next topic. So if we have, instead of two sets, if we have three sets, then what will be the formula? If A, B and C are finite sets, then A union B union C is equivalent to A plus B plus C. Okay, so we are adding A, B and C. After that, we are supposed to remove the ones, this A, B, we have added A intersection B twice. So we are removing A intersection B. Similarly, B intersection C and A intersection C. After that, once we have removed these three, then later on we have to, this is plus actually. Later on, this middle part has been removed thrice. So for A intersection B, we were removing this part. For A intersection C, we removed again, and we have removed it three times. Now, because it has been removed three times, it was added three times. Okay, but it has been removed three times. So this part is completely excluded. For that reason, we have to add the part which has been intersecting at the point where all three are intersecting. So plus A intersection B intersection C. So this is the formula if we have three sets.